So, today's topic is about scheduling algorithm in OS, which is a very important topic and very interesting too. So, let us discuss one by one. Scheduling algorithms. So, we have seen the number of processes in the ready queue and it has to be navigated to the running state in the last class. Am I right? So, this type of navigation from the ready state to the running state has to be done and will be done by a special unit known as a scheduler. Okay, because we are aware that all the processors which are in the ready queue will be allocated to the CPU one by one or priority basis or by any means it has to be allocated to the CPU, and for this allocation a special unit known as scheduler has been designed, and this scheduler will take in charge of this allocation of the processors to the CPU. And this is the major concept we are going to see in scheduling algorithm. So, the scheduler it itself will decide which process has to be allocated to the CPU. It itself will decide from the n number of processors which will be in the ready state and it has to be moved to the running state. So, this navigation of the ready state to the running state will be done by this special unit known as scheduler. So, the scheduler, how will it allocates this n number of process, how it chooses which process has to be allocated one by one to the CPU. So, that is the main task of this scheduler and how the processes will be allocated. So, for this it chooses, the scheduler chooses some types of algorithms based on some concepts, some types of algorithms it chooses, and these algorithms are defined as scheduling algorithms. So, there are various types of scheduling algorithms and we are going to see one by one. Clear? So, the next step of the scheduling algorithm will be the types of scheduling algorithms. So, how many types we have in scheduling algorithms, and based on these algorithms the scheduler will chooses a particular one for this navigation. So, the first one will be first come first serve. The acronym FCFS stands for first come first serve. So, that is first algorithm of the scheduling. Then next one will be shortest job first, SJF. The acronym stands for shortest job first. And the third one will be priority scheduling. Fourth, round Robin scheduling. Fifth one will be shortest remaining time. Shortest remaining time algorithm. And last one, multiple level queue scheduling. So, these are some of the common types of scheduling algorithm. First come first serve, shortest job first, priority scheduling, round robin scheduling, shortest remaining time, multiple levels queue scheduling. So, these are the basic types of scheduling algorithms, and with these types the scheduler will chooses any one based on some of the concepts of the processors, and it will be allocated to the CPU. So, let us come to the first one. Before proceeding with first come first serve, basically there will be two modes in which acts as a common thing for all types of algorithms. So, there will be two modes. One is non-preemptive and another one is preemptive. So, what actually means non-preemptive and preemptive? Non-preemptive is the thing that it accepts no interruption. It's very simple to say that it accepts no interruption and it accepts interruption. So, you may ask, ma'am, what do you mean by accepts no interruption and accepts interruption? So, the basic difference between the two terms is, whenever a process is being executed, that is, if among n number of processes, if a particular process is in execution by the CPU, at that process it's been completed or it is being tasked by the CPU, and if any other processes from the ready queue, it is asking for a request, means the CPU will not allow those processes even though if that particular process is having highest priority. So, the process which is asking for a request with the highest priority, it won't be accepted by the CPU. So, that is known as accepts no interruption. Only after the completion of the current process, the CPU will be accepting the other process which is in the ready queue. So, that is known as accepts no interruption, whatever may be the priority of the next processes. And accepts interruption means, if there are n number of processes and if a process has been in the completion task and it is being processed by the CPU, even though if any other process having highest priority, it will be allocated and it will be sent to the CPU. So, that is the term defined as accepts interruption. I think you may now clear with these two terms, am I right? So, accepts interruption, no interruption means any processes with the highest priority, even though if they ask request to the CPU, it won't be allowed to the completion of the task. Only by the execution of the current task, the CPU will accept the next process. And accepts interruption means even though if the current process has not completed its execution, if any other process in the ready queue, if it asks for the priority, if it has asked for the request, means it accepts and that process will be allocated to the CPU. So, that is the major difference between these two things. And I think I may proceed. Am I right? Yes. So, all these algorithms will be based on these two modes only. Either it will be preemptive or it will be non-preemptive. So, coming to first come first serve, the mode will be non-preemptive. Means that if any other processors which are in the ready queue, if it is asking a request to the CPU, means that process will not be accepted. Only the current process which is under execution will be allowed to complete its task, and whatever the process based on the arrival time will be allocated to the CPU. So, non-preemptive and it is based on the arrival time. So, that is the major thing in first come first serve. Clear? Non-preemptive and it is based on the arrival time. So, first come first serve, as the name implies, whichever process has entered the ready queue in the first manner, that is first which process has entered, based on its arrival time it will be responded. So, let me have a tabular column related to this. So, basically in scheduling algorithm, you will be asked to calculate the completion time, average turnaround time. Let me come to this one by one. In the types of algorithms, we are going to see about FCFS, first come first serve algorithm. So, this is the first algorithm, that is in types of scheduling. This will be the first one and this will be the simplest algorithm. So, mode will be non-preemptive and it is based on the arrival time. So, this is a very important one, and the concept for FCFS, the mode will be non-preemptive. Non-preemptive, as I have mentioned you earlier, whichever the process in the ready queue, if it is asking for request to the CPU, it won't be accepted. Only the process which is under execution, after completing its task, the next process will be given priority. So, mode will be non-preemptive and it is based on the arrival time. Arrival time means whichever process has entered the queue as a first, it will be given, it will be responded. So, for all of these things, a tabular column will be given to you. S number or the process number and the arrival time or relative time, burst time, completion time, turn around time, waiting time. So, these are the time intervals we are supposed to calculate for each of the thing. So, process say for example process P1, P2, P3, P4, P5. So, the process P1 has entered in 0 millisecond and it is in 1 millisecond, 2, 3 and 4, which means that the process P1 has entered the ready queue in 0 millisecond. So, this is the first process to enter into the ready queue. Then next comes the process P2, then P3 which has arrived in 2 milliseconds, P4 in 3 milliseconds, P5 in 4 milliseconds. So, this is the time interval which the process, all the process has entered into the ready queue. And burst time, arrival time, let me have a definition for the arrival time, because guys, you know down the definitions for each of the terms, because you will be awarded marks for each of the definitions. Although you are supposed to calculate the Gantt chart, I mean all these time intervals using Gantt chart, it's very important to for you to write the definition for each of the terms. So, arrival time is the time entered by each of the process. And the burst time is the time taken by the process to fetch the CPU. So, arrival time, the process has entered the ready queue, and the burst time, how long it takes to fetch the CPU, when at what time interval that particular process has got the CPU, has received the CPU. Say for example, is the time interval taken by each of the process to complete its process. So, approximately I have given the time intervals for each of the process to, that is process P1 has waited for 5 milliseconds to get the CPU, and this is 4, process P3 6, process P4 4 and process P5 5. So, this is the time interval taken by each of the process to get the CPU. From this, we are going to calculate the completion time, turnaround time and waiting time. How all these things will be calculated? So, it will be calculated by means of Gantt chart. What do you mean by Gantt chart? So, so, the process P1 has entered in 0 millisecond and it got the CPU in 5. So, the process P1 has entered in 0 millisecond and it has taken 5 milliseconds to get the CPU. Then next comes, based on the arrival time, the next process will be P2. So, it will be allocated into the running state, and how long it takes? 4 milliseconds. So, already it has entered in 5 and it took 4 milliseconds to fetch the CPU. So, 5 plus 4, 9. So, in 9th millisecond, the process P2 has taken the CPU for its execution. So, based on the arrival time, the next process allocated will be P3. So, P3, it took 6 milliseconds to fetch the CPU. So, 9 plus 6, 15. 14, 15, yes, 15 milliseconds to fetch the CPU. And based on the arrival time, the next process allocation will be P4. So, P4, how long it takes to fetch the CPU? 4. So, already it has entered the ready queue in 15 milliseconds and it has taken 4 milliseconds for its fetching. So, 15 plus 4, 19. Denote me if there is any mismatch in my calculation. And the last process to enter into the ready queue will be P5 and P5 and it took 5 milliseconds. So, 24. So, the process P1 has entered in 0 and it has taken 5 to fetch the CPU, and process P2 has entered in 5 and it has taken 9 milliseconds to get the CPU. P3 has entered in 9 and it has taken 15. P4 has entered in 15 and it has taken 19, and P5 has entered in 19 and it has taken 24 milliseconds. So, based on this, we are supposed to calculate the completion time. So, what is the completion time of the process P1? So, it has entered in this and it has it has taken this much to get the CPU. Then process P2 has completed in 9 milliseconds. Process P3 has completed in 15 milliseconds. Process P4 has completed in 19. And at last process P5 has completed in 24. So, this is the completion time and this is the burst time. Based on this, we are going to calculate the turnaround time. How the turnaround time will be calculated? Basically, turnaround time will be the time difference between the completion time and the arrival time. So, difference between the completion time and the arrival time. So, based on this definition, what is the turnaround time for the process P1? 5 minus 0 is 5. 9 minus 1 for the process P2, 9 minus 1 is 8. Process P3, 15 minus 2 is 13. Process P4, 19 minus 3 is 16. Process P5, 24 minus 4 is 20. So, this is the turnaround time for each of the process, which means the completion time minus the arrival time. So, process P1 completion time is 5 and the arrival time is 0. So, difference is 5 minus 0 is 5. Then process P2 9 and the arrival time is 1, 9 minus 1 is 8. Likewise, 15 minus 2, 19 minus 3, 24 minus 4. So, this is the turnaround time, and next comes the waiting time. Shall I rub all these things, because I think you have taken down the definition for all of arrival time, burst time and all these things. So, may have a rub on all these things. Then waiting time. How we are going to calculate the waiting time? Difference between the turnaround time and the burst time denotes the waiting time. difference in the time interval between the turnaround time and the burst time. So, waiting time, difference between the turnaround time and the burst time. So, 5 minus 5 is 0. 8 minus 4 is 4. 13 minus 6 is 7. 16 minus 4 is 12. 20 minus 5 is 15. So, this is the waiting time for each of the process. Clear? And from this, we are going to calculate average turnaround time and average waiting time. So, average means turnaround time plus the number of processes. So, what's the average? Turnaround time 5 plus average turnaround time equal to 5 plus 8 plus 13 plus 16 plus 20 divided by the number of processes. So, number of processes 5. 8 plus 5, 13, 26, 26, 6, 42, if I am not wrong, 42 plus 20, 62. So, 62 divided by 5, 12 point approximately. So, this is the average turnaround time for this tabular column. So, 12 and average waiting time. What's the average waiting time? This is the waiting time and 0 plus 4 plus 7 plus 12 plus 15. So, divided by the number of process 1, 2, 3, 4, 5. On addition of these, this gives the average waiting time. So, this is the completion of FCFS on the calculation of completion time, turnaround time, waiting time, average turnaround time and average waiting time. So, likewise, now we are going to see a different example and you will be asked to calculate a data will be given to you, say for example S number or process number, arrival time and burst time. So, this is the exercise I am giving for you to work out now, and from this you are supposed to calculate the average turnaround time and average waiting time for this tabular column. So, this will be the question given to you. From this tabular column you are supposed to calculate the average turnaround time and average waiting time. So, process P1, P2, P3, P4, and the arrival time will be 0, 1, 2, 3, and the burst time, say for example 5, 4, 9, 8. So, I'll ask any one of you to in a random manner to come to the board and execute it, and I'll give 5 minutes for you to complete this task. Okay. So, any one of you, I'll ask you to come. So, everyone, you work out this problem in your notebook and let me know. I'll give 5 minutes for you. Clear?